Like I've said before, matrices can be used in terms of solving systems of equations. And you use inverse matrices in order to solve those systems. But in order to solve those systems, you need to find the determinant. And that's what this video is going to be about specifically. A determinant has to be a square matrix. And what that means is that a square matrix has the same dimensions in terms of your rows and your columns. We're starting with a 2 by 2, and then we'll move up to a 3 by 3. So if I have the matrix 2, 6, 1, 4, if I'm looking for the matrix, I take the diagonals going left to right, subtract the diagonals from right to left. So what that means in this case, I'm going to take the diagonals of 2 times 4. That's my only diagonal currently. And then I'm going to subtract off the diagonal going the other direction. So 6 minus 1. Or 6 times 1, sorry. So this is going to give me my determinant then. I'd have 8 minus 6 to give me my determinant of 2. Okay, so when you're looking at a 2 by 2 matrix, it's a little bit easier to work with just because you only have one diagonal minus the other diagonal. When you're dealing with a 3 by 3 matrix, it's a little bit trickier because you've got lots of diagonals. Try to keep these numbers small for you. That way it's a little bit easier to keep track of what's going on. So let's say I've got the matrix 1, 0, negative 1, 2, 3, 1, 0, negative 2, and 1. So my diagonals on this, you're actually going to have 3 sets of diagonals, and then you're going to subtract off another 3 sets. So we're going to look at the left to right ones first. So if I'm looking at left to right, I've got 1 times 3 times 1. I'll have another diagonal of 0, 1, and 0. And then my last diagonal that you can see going left to right is going to be that negative 1 times 2 times negative 2. Sorry, kind of cut off on my board there. So that's my final diagonal going left to right. Now I'm going to go with the right to left diagonals. And you always start in the top corner. So in this case, since I'm going right to left, I'm starting in the top right corner. So I have negative 1, 3, and 0 to start off with. And I keep working my way left. So my next diagonal is going to be that 0, 2, 1. And my last one is going to be that 1 times negative 2. So now I've got to add all of my diagonals going left to right, and then I'm going to subtract off my diagonals going right to left. So if I look at the top, I've got 3 plus 4, so it's going to give me 7. My right to left, I'm going to have 0 plus negative 2. So now, like I did before, I'm subtracting my diagonals. So 7 minus negative 2 gives me a positive 9. Again, we'll do another one of these just as good measure because it can get kind of confusing. So let's have our second matrix here still be a 3 by 3. We're going to go with 2, 4, negative 1, 1, 0, negative 2, 2, 3, 3. This time I'm going to, instead of highlighting, I'm just going to use just my regular pen colors here. So again, I'm going left to right. Let's start off my diagonals. So I've got the 2, 0, and 3. plus the 4, negative 2, and 2. And my last diagonal is that negative 1, 1, and 3. I'm going to go ahead and add these up. I gave myself room this time. So in the red, I've got 0. In the green, I have a negative 16. In the blue, I have a negative 3, so that's going to give me a negative 19. Now I'm going to go right to left. So I've got negative 1, 0, and 2. Then I've got, ooh, that's too close of a color, sorry. That 4, 1, and 3. And if I pick yellow, yellow will be too bright to see. Let's go with a teal color. So then my last diagonal is that negative 2, or that 2, negative 2, and positive 3. Sorry if you can't see this. All right, so when I add those together, I've got 0 plus 12, and then I'd have plus a negative 12. So that limits it down to 0 then. So negative 19 minus 0 gives me negative 19 as my determinant. So hopefully with that color coordination there, that kind of helped. Plus you get a nice pretty square with lots of colors of the rainbow.